means how we can calculate this part. So beside this one, there is some formula, that means in case of I have calculated maximum velocity. So now we have to discuss one more topic, which is called maximum acceleration. That means how we can calculate the maximum velocity and maximum acceleration. So first you see maximum acceleration. So before discuss the maximum accelerations, so you should know the acceleration of simple harmonic motion. So write down acceleration of simple harmonic motion. So in simple way, I am giving to you acceleration of simple harmonic motion means this is the equation already you know. Y is equal to A sin omega t. This is a normal equation, the normal formula. So dy by dt we can write A cos omega t like this. So we have to calculate the value of acceleration. Now see here also omega. So again differentiate it, double derivative already I discussed earlier. So here we can write A omega minus here sin omega t into omega. So here acceleration, here omega square we can write like this. So this is the value of acceleration. So next number 10 number formula, you can see the maximum that means acceleration will be minus omega square y. This is the formula. So this is the formula for acceleration. Now for maximum accelerations, so what is the maximum acceleration? So maximum acceleration. So for maximum acceleration, you always remember. So suppose y it is given a sin omega t here. So dy by dt, in this case you can see a omega cos omega t like this. So here d again differentiate d square y by dt square like this. So we will get minus here you can see already I have given up to this, that means minus omega square a sin omega t. So you always remember here a max maximum acceleration will be here when the value of omega t is equal to pi by 2, that means it will be omega square a. So but one thing you remember, minus sign will be there. So here omega t means I consider the angle is pi by 2, that means when omega t is equal to pi by 2, then it will be maximum acceleration. But in this case you can see this is a kind of relation in which negative sign is there. So negative, if any bigger value is there but negative sign in front the bigger value, then it will be very small. So but I have written maximum, that is why you have to take modulus symbol. So after taking modulus, so that means a max we can write omega square a. So 11 number, here you can see 11 number formula will be omega square. So we can write a is a max we can write omega square a. This is the formula. So dear students, you remember this is a very important chapter which is completely related with mathematics, and mathematics is applicable in this oscillation sector. So maximum acceleration we are getting omega square a. Now I am going to discuss one numericals related with the normal acceleration and maximum acceleration. So you can see suppose you have given. So these are the formula, all the formula I am going to discuss. So you can see here, suppose I am going to discuss about the acceleration and maximum acceleration. So how we can solve the acceleration and maximum acceleration as a numericals. Suppose you have given, one question is given, y is equal to suppose 3 sin 5 pi t, 3 sin 5 pi t, it is given. So in short, find maximum find acceleration and maximum acceleration, maximum acceleration. So we have to calculate. In short, I have given the questions. If y is equal to 3 sine 5 phi t, 5 phi t, and find the acceleration and maximum acceleration. So you can see here, this is the relations. Okay. So dear students, you can see this. In short, I have given the question. So y is equal to, it is given 3 sine 5 phi t. It is given like this. So in this case, y is equal to here a sine omega t. Now you always remember y is equal to 3 sine 5 phi t and y is equal to a sine omega t. So if you compare this one, you will get a is equal to 3 meter and omega you are getting 5 phi, because tt cancel. So omega is equal to, we will get 5 pi. So in this case, we have to calculate the value of here this maximum displacement as well as maximum velocity we have to calculate. Now in this case, you can see how we can calculate the value of this one, maximum acceleration. So normally the maximum acceleration, a max is equal to omega square, this is the formula, omega square e. So this value we are getting, omega means 5 pi, it will be 5 pi whole square into amplitude is given 3, so it will be 25 into pi square into 3. So you always remember pi square always it is 10, so that is why 25 into 3 70, 75 into 10 750. So pi square means always 3.3, that means whole square, it will be 10. So 750 is the meter per second square. Now I have written here acceleration. You can see how we can calculate the value of acceleration. So this part I am going to discuss the next example. So normally in case of acceleration, suppose if you are going to find the acceleration, at first you have to calculate the value of here minus, that means a is equal to minus omega square y is given, so we have to calculate the displacement value will be given, but in this case displacement not given. So that is why when you are going to calculate the value of acceleration, the displacement will be given. So after knowing the displacement, you can easily calculate the value of omega. Now you can see here, suppose one question. So how the question is related, very important topic this one. Suppose you have given, suppose like this, if one relation is given, if a is equal to 4 pi, if it is given 4 pi, it is given 4 pi y is equal to 0. It is given a plus 4 pi y is equal to 0. So if it is given like this, so in this case the time period will be, in this case, what is the time period? So if a plus 4 pi y, so it is given to you, so the time period will be, that means option A, time period is given suppose 1 second, B it is given suppose 3 second, and C it is given suppose 4 second, T is equal to 4 second, and D it is given none it is given. So how we can calculate this one? So normally suppose it is 4 pi square, so a plus 4 pi square. So what is the solution? You can see this is the solution. So solution, how we can calculate? So here a is given, a plus 4 pi square y it is given is equal to 0. So in this case we can write a is equal to minus 4 pi square y like this. So this is the equation number 1, and normal equation of acceleration already you know, minus omega square y. So this is equation number 2. If minus was cancelled, so omega square is equal to 4 pi square. So in this case, you can see omega square is equal to twice pi whole square, we can write. So this one cancel. So omega is equal to twice pi. Omega means twice pi by t is equal to twice pi. So it will be 1. So cancel. So ultimately t is equal to 1 second. So the answer will be this one. So in this way we can easily calculate the value of any equations if it is given in terms of your equation of simple harmonic motion. So this part is over. So maximum velocity, normal velocity, equation of simple harmonic motion, maximum acceleration, normal acceleration, done. This one done. Next you can see, so I am going to discuss this one question. Suppose B is equal to nu lambda and nu is equal to 1 by t. In this case you remember, suppose you have given this formula B is equal to, suppose this formula B is equal to nu lambda. So basically I have given one more formula, omega, that means twice pi n by t. This is a kind of formula already mentioned. So suppose you have given one question, suppose wheel of a car rotates, wheel of a car rotates 60 rpm, rotation per minute. Meaning you always remember rpm, rps, rotation per second, and rotation per minute you always remember. Rotation per second. If it is mentioned here rpm, this represent rotation per minute. On the other hand, if it is given 60 rps, then you always remember 60 rps means rotation per second. So in this case, wheel of a car rotates, wheel of a car rotates 60 rotation per minute. So what is the angular velocity or angular frequency? What is the angular frequency? We have to calculate the angular frequency. So in this case you always remember the here given rotation per minute. What is the formula? So normally angular frequency omega we know that twice pi nu. This is the formula. So nu means frequency. So in this case twice pi. Here n by t, it will be like this. Here 60 rotation per minute. That means per minute the wheel rotates 60 times. So that is why twice pi into 60 per minute. Per minute means here 1 minute. 1 minute means 60 seconds. So it will be twice pi radian per second. So this is the answer. So maybe it is given in the form of option questions. That means A will be suppose twice pi radian per second, and B means it is given in this way. B means suppose pi by 2 radian per second, and C number may be given 2 by pi radian per second, and number D none of this. In this way they can give to you. Now one thing you always remember, in this case we have used this formula omega is equal to twice pi nu is equal to twice pi n by t. That means the final formula we are getting twice pi radian per second. Next you can see this formula is over. So it is given number of rotations. So in case of one rotation it will be 1. In case of n number of rotation it will be n. So dear students, you always remember, in case of this chapter you have to be very strong in mathematical part. Now you can see this part is discussed already. I have discussed this part already. So this all the part already I have discussed. Now this is the equation of simple harmonic motion, velocity, acceleration, maximum acceleration already I have given to you. Now thing is that what is the total energy? Total energy. What is the value of total energy in case of simple harmonic motion? So now let us come back. Energy of simple harmonic motion. Energy of simple harmonic motion. So when we are talking about the energy, you always remember energy, there are different types of energy. So what are the energy you are getting? So basically we are getting different types of energy. Number one, potential energy. Number two, kinetic energy. 3, mechanical energy. 4, geothermal energy. 5, heating energy, electrical energy, then wind energy. So there are different types of energy, but according to our syllabus of C exam, you remember only potential energy, kinetic energy, mechanical energy basically used. And here we are going to calculate the energy. When we are talking about the energy, it is the sum of potential energy as well as kinetic energy. So now it will be total energy. That means kinetic energy plus potential energy. So EP will be the potential energy. So when we are talking about the energy, E is equal to potential energy plus kinetic energy. So what is the potential energy? So you should know. So here in this case number 12, what is the potential energy? What is the kinetic energy? What is the value of kinetic energy? Now see, already I have given the velocity is equal to omega under root a square minus y square in case of simple harmonic motion. Now see, kinetic energy means Ek is equal to half mb square. So it will be half m a square minus y square. So this is the value of kinetic energy. So we can use here kinetic energy. The value of kinetic energy, it is given half m a square minus y square. Now you can see the plus is here. So we have to calculate the value of potential energy. So what is the value of potential energy? So potential energy is equal to EP is equal to, you always remember there is a one formula. It will be half m y square, in short I have written. So it will be here omega value is also there. Here omega also there. So you have to mention omega also. So in this case it will be half m omega, and here also half m omega y square. This is the already potential energy already know. So that is why kinetic energy, in this kinetic energy half m omega, that means b square. Here you can see where b square means this value is square, it will be square, that means you just write like this. Final value you can write like this. So b is equal to, we know that a square minus y square. So here b square is equal to omega square a square minus y square. So when we are talking about the kinetic energy, half mb square, here also half m, it will be omega square a square minus y square. So this is the kinetic energy. So Ek is equal to half m omega square a square minus y square. So dear students, you can write as a formula. So formula number 12, kinetic energy is equal to half m omega square a square minus y square. Now in this case, if you put the value here, then we will get some value, and potential energy also we already we know half m omega square y square. So after adding, that means if you add this one, that means EP Ek plus EP, then we will get, so this value will be cancelled, that means half m omega square a square minus half m omega square y square here, and plus half m omega square and y square. So this value cancel. So total energy will be half m omega square a square. So this is your total energy. So we are getting three types of formula here in case of simple harmonic motion. One is potential energy, kinetic energy. So potential energy will be your half m omega square y square. This is the potential energy. And total energy, when we are talking about the total energy, we can write half m omega square a square. So this is called total energy. So in this way we can easily calculate the value of potential energy and kinetic energy. So the question may be given like this: which of the following is the correct option for total energy of simple harmonic motion? Otherwise the question will be given like this: the total energy of simple harmonic motion is represented by represent option E. It is given, suppose half m omega square a square. B, it will be half m omega square y square. C, it is given half m omega square, and here m omega square, and D number none. So this is the correct answer for the question. So the total energy of simple harmonic motion is represents which of the simple harmonic motion? The first one is the simple harmonic motion. It is the representation of simple harmonic motion. So in this way, dear students, you always remember this formula, because here some numericals and formula is very important for the CEE exam. Now see, I have given this total energy. This is the total energy. Now you can say next topic will be your that means frequency or time period of spring. So normally when we are talking about the spring, that means time period of spring. So time period of spring. So basically you remember this is the conception. So how the time period of spring means when you are acting the force on the spring, there is a oscillation, there is a vibration. So per second, what is the time? That time we are going to calculate. This is a time period. So in this case, I am going to draw three diagram. You can see, suppose this is a kind of spring. This is the normal position of the spring. That means initial position of the spring, and this initial position basically represented by A. Now when this spring is loaded, when this is a load, B position. So initially the spring was at position A. Now second part, when the load is applied on the spring, and due to the load there is a extension, and this extension it is represented by X in this case. And after, you can see C positions. After C position, you can see when the load is removed from the spring, then it will be minus X. So C position. Now see, so initially when the spring is loaded, so after loading there is a extension. This extension basically represented by X, and when the load is removed from the spring, then there is a minus X. That means there is a contraction. So after sometimes it will come back to the original position. So that is why you remember in these explanations we can use here two types of condition. Force is directly proportional X. In this case we can write force is directly proportional X, but in this case we can write force is directly proportional minus X. So both the condition is applicable in this case. Both the condition is very important. So you remember in this case we can use suppose I am taking these conditions. So F is equal to, we can write Kx. So what is the meaning of K? K here is spring constant. So this spring constant basically represented by K. So we can write here F means ME is equal to minus Kx. So dear students, already I have given this formula. A is equal to the acceleration. Here you can see serial number 10, it is given the acceleration of the simple harmonic motion A is equal to minus omega square y. But in the given formula, I have given displacement y, but here I have given displacement x. So we can write m, that means it will be omega square y or omega square x, it is minus kx. So in this case, minus cancel, x is cancel. So we can write m omega square k. K is a spring constant. So we can write omega square is equal to k by m. So k by m. So omega is equal to, we can write under root k by m. Now you can see I have given this formula, omega means twice pi by t. Twice pi by t is equal to under root k by m. So in this case, t is equal to twice pi under root m by k. This is a kind of formula. This is the time period of spring. So when the time period of spring it is given, t is equal to twice pi under root m by k. So here you can see k is a spring constant. So now this formula we can also modify. So 13 number formula, t is equal to twice pi under root m by k. So you remember 13 number formula, t is equal to twice pi under root m by k. M is a mass and k is a spring constant. Now this is the formula for time period of spring. So dear students, already you know in class 12, in class 10 you got the resistance in series, resistance in parallel connection. So here also springs we can also connect it in series and spring we can also connect it in parallel. So instead this is the equivalent spring constant. So this spring constant we can also convert into equivalent spring constant in terms of series connection in case of parallel connection. So this is the idea. So in this way we can easily calculate the value of time period of a spring. Now see next, simple pendulum. This is the part of the topic which is called simple pendulum. Simple pendulum. So when we are talking about the simple pendulum, simple pendulum. So dear students, simple pendulum. So what is the meaning of simple pendulum? Pendulum basically oscillation, vibration is there. Simple pendulum normally when the, suppose this is a kind of rigid support, the first starting class is a C, there is oscillation, vibration I have given. So in this case the time period of a simple pendulum, t is equal to twice pi under root L by Z. This is the expression. This is the expression or this is the time period of a simple pendulum. So dear students, you always remember during the motion of a pendulum, there is a three types of forces will act on the pendulum. Normally mg, weight of the object, weight of the bow, and here you can see mg cos theta, mg sin theta. So three types of forces we are getting. One is mg, mg cos theta, mg sin theta. These are the component of the forces. So you remember there are three forces we are getting. One force during the vibrations, one force as a note we can write. This is a kind of formula. So in this case number 14 we can write t is equal to twice pi under root L by Z. Now force is equal to mg. That means this is the weight, this is a kind of force, and again force we can write mg cos theta, again mg sin theta. These are the components of the forces during the motion of the simple harmonic motion. Now see, in this case, you remember when we are talking about the simple pendulum, already I have given this is the time period, t is equal to twice pi. This is the formula, t is equal to twice pi under root L by Z. So you remember, suppose t is a time period, L is a length, and Z means acceleration due to gravity, and here twice pi is a constant. Suppose using this formula, how we can solve the numerical? Suppose you have given one question. So time period of a pendulum, time period of a simple pendulum, time period of a simple pendulum is 2 seconds. Suppose I have given the time period of a simple pendulum is 2 seconds. So if the length, if the length of the simple pendulum, if the length of the simple pendulum reduced to half, reduced to half of its original length, half of its original length. So in this case, what is the new time period of the pendulum? So what is the new time period? What is the new time period of the pendulum? What is the new time period of the pendulum? Now see, time period of a simple pendulum, it is given 2 seconds. So already you know this is the formula. T is equal to twice pi under root L by Z. So according to our question, the first case it is given T, the value of T it is given 2 seconds. After that, in case of second case, you can see half of its original length. So when the length of the pendulum is reduced to half, what will be the change of the time period? So in this case, you can see the solution. In shortcut way I am giving to you. So normally formula is T is equal to twice pi under root L by Z. So the value of time period of simple pendulum, it is given 2 seconds. So I have written here 2. So L by Z. This is your equation number 1. Second case, when the length of the simple pendulum reduced to half, that means you can see twice pi here under root L reduced to half, that means L by 2, here Z. So what is the time period? T dash. That means new time period will be T dash. So in this case, you can see twice pi here under root 2, we can write L by Z. So in this case, you can write 1 by root T into time. Time means it is given 2 seconds from equation number 1. We can write like this. So this value we can write 2 means we can write 2 into 2 here root 2. So time period, new time period will be root 2. So dear students, you can see in this way you have to solve all the numericals related to the time period of the simple pendulum. Only you have to remember, if the length is increases or length is reduced, then you always remember you have to solve using this formula. So thank you so much. You have to practice and you always remember the whole formula already I have given today. So you memorize this formula, practice this formula, so you can easily solve. Thank you so much.